Hello, grade 9s. Today we're going on to similar triangles, working from slides 1 to 13 from the Similarity and Congruency PowerPoint. Now, before I go into any of this, I just want to talk about what similarity is. Similarity is the two shapes are identical in terms of their angles, okay? So they'll have exactly the same angles, but the one shape will either be bigger or smaller. So if you have a look at these two triangles here, you can see that the one is smaller than the other, but if you have a look at their angles are the same. Okay, so they are similar in terms of that. All right. The sign or the symbol that we use for similarity is these three lines going down like this. Okay. Just to note here, a couple of things. If two pairs of corresponding angles of two triangles are equal, then the third pair will also be equal. Now, what that means is, if you have a look here, we have 60, 60, 45, 45. So that's what they're talking about here. If two pairs of corresponding angles of two triangles are equal. So we have two pairs of angles are equal there. That means we're not given this third angle, but it means that these two angles will be equal. Okay, because you can see here, you know that angles in a triangle add up to 360. So just for this one over here, if I go 180 minus 60 minus 45, I get 75. So that angle will be 75. It will be exactly the same for this triangle over here. This will also be 75. So you don't have to be given the third angle. If you're given two pairs are equal, the third angle will automatically be equal. Okay. Now, I'm going to go on to two conditions for similarity. These are important, so please pay special attention to them. So condition 1 is equiangular, and we say AAA for angle, angle, angle. So in this example here, we have a triangle PQR and a triangle KLM. Now, I've color-coded it here. You can see that angle P is equal to angle K, angle Q is equal to angle L, and angle R is equal to angle M. Okay, so these triangles will be similar. All the angles are equal, and you can see the one is smaller than the other one. So they're exactly the same in terms of their angles, but their sides are a little bit longer. Okay, so if we have this situation where all three angles are equal to each other, therefore we say that triangle PQR is similar to triangle KLM. And our reason for that is angle, angle, angle. Now, grade 9s, your order here is important. So if I started with angle P here for this triangle, I must start with angle K for this one because they are the equal ones. Then if I go to angle Q like this, then I must go to angle L. Then angle R is equal to angle M, so RM, okay? I can't go like this, PQ, and then for this one, KM, okay? Because they are not equal, this K, this Q, and this M. You must follow that order where they are equal, all right? So condition 1, equiangular, AAA. Then, condition 2. Now, as you guys saw with these, the previous triangles there, your angles are all equal, but the one triangle is bigger or smaller than the other one, but the sides will be in proportion. So, for example, condition 2 is corresponding sides are in proportion. So, let's just say that this triangle is 3 times larger than the smaller one. That means all of the sides will have that factor of 3 in it, okay? So whatever side this one is, we multiply it by 3 to get this one. Whatever the length of this side is, we multiply by 3 to get to this one. Whatever the length of this one is, we multiply it by 3 to get to this one, okay? So you will always get that constant of proportion coming out, all right? It can work the other way around. We can take this side, divide it by a number to get that one. Take this side, divide by a number to get this one, and take this side, divide by that same number to get this one, okay? So this one could be a third smaller than this one, So you can see here, I've color coded it again. If we take PQ divided by KL, and then if we take QR divided by LM, and then PR divided by KM, we will get that same number coming out. So like I used that example, this one is 3 times larger than this one. So we expect all the 3 sides to have that factor of 3 in it. Okay, that's just an example. Now, if the sides are in proportion, therefore we can say that triangle PQR, now just follow the order, PQR, then we'd have to go KLM, triangle KLM, and the reason for that is corresponding sides in proportion. Okay, so we have 2 conditions to prove similarity. The first one is AAA, equiangular, and the other one is sides in proportion. Okay, and we are going to use those 2 conditions to prove triangles are similar. So let's have a look at some examples. So example 1. The slides for these will be posted up for you grade 9, so you can follow it from there. So example 1 is saying to us, determine the values of P and Q if this triangle PQR is similar to triangle TVS. That's what they've told us. So we know that this was given to us, that triangle PQR is similar to triangle TVS. They told us that. Okay. Now, from this, what I'm going to do, I just want to show you how I get my little fractions coming up. And I'm going to use condition 2. So I'm going to get these little fractions. That's what I'm talking about, grade 9s. And it's quite easy. So if they've given you the similarity, all you have to do is you just hop. So I'm going to say that one over that one. So therefore, we've got that PQ over TV will be equal to, now we do the next hop, which is that one and that one, that one and that one. So it'll be now QR over VS. And we've got one more hop, that one and that one. So now it's PR over TS. Okay, so this was condition 2 that I used. Now, I must just give reasons for these 2 statements. So this first one, this information was given to us. The second one, I'm going to use the reason that I showed you guys over here for condition 2, which is corresponding sides in proportion. Okay, so my reason for this one is corresponding sides in proportion. Okay, so what I'm going to do now is I'm actually going to fill in the values for PQ, TV, QR, VS, PR, TS from my triangles over here. So PQ, you can see PQ is 7, so we get 7 over TV, TV is 28, equals QR is 9, over VS is Q, equals PR is P, over TS is 20. Okay, so our 2 unknowns that they asked us to solve, there's the one, the Q, and there's the other one, P. And what I'm going to do is I'm going to look for one of the fractions that has all the information. In other words, the numerator and the denominator. And it's this one over here. The 7 over 28 has both the numerator and the denominator. These 2 fractions over here have our 2 unknowns. So what I'm going to do is I'm going to break it down. I'm going to say the first one is going to be 7 over 28 will be equal to 9 over Q. That is the one. The other one I'm going to work with is now this one with our known. Okay, so we're going to get 7 over 28 is equal to P over 20. Now we have an equation that we can solve for both Q and P. So for this first one here, I'm going to multiply up by Q. Okay, so we get 7 over 28 multiplied by Q equals 9. What I'm going to do now to get the Q on its own is I'm going to divide both sides by the 7 over 28. So we get 9 divided by 7 over 28. And remember grade 9s, if you're dividing by a fraction, you tip and times. So we get Q is equal to 9 times 28 over 7. And you can put that on the calculator if you want. So we can say 9 times 28 over 7, and we'll get 36. All right, so that's our one that we solved. Now I must just solve for this one. So to get the P on its own, we have to multiply both sides by 20. So this one will be 7 over 28 multiplied by 20 equals P. So here we can put this now on the calculator. 7 over 28 multiplied by 20, and we get 5. So 5 is equal to P. And we've solved for both P and Q, what they've asked. Okay.